Okay, let's give an example of where you can use the definite integral to compute, say, area. Here we're going to find the exact area between the x-axis and the graph of e to the 2x between x equals -1 and x equals 2. So whenever you see a problem like this, it's a good idea. You have a graphing calculator. You might as well graph the function and get a look at what things look like. So if you do that, you'll see the graph of e to the 2x looks something like this if you have the right window set. And if we want to find the area between x equals -1 and 2, and this area is going to be starting at -1 and going up to 2, and we're between the x-axis and this graph of this function e to the 2x, so that area that we want to find is this area. Okay, so you could use your graphic calculator to see this. That gives you an idea what's happening. And we recall that the definite integral is an expression for the area. So the definite integral between -1 and 2 of e to the 2x dx, that'll give you the exact area. Okay, at this point you might say, okay, I'll just use my calculator and figure out what the answer is. And if you plug into your calculator, you get something like 27.23140,130,737. Okay, that's wrong. Absolutely wrong. Why? Because here we're asked to find the exact area, and your calculator only computes Riemann sums. It only finds a approximation of the area. We want the exact area, so we're going to have to do this by hand. We're going to have to compute this integral. Okay, to do that, one way to do this is by substitution. I'm going to let u equal 2x. du is going to be equal to 2 dx. And so this integral that I need to compute is going to be equal to the integral from e to the u. And then the dx is the same as du over 2. So I write du over 2 for that integral. And if you want to, you can leave these blank, or you could figure out what the new limits of integration are. I'll leave them blank. An antiderivative for this will be 1/2 e to the u, and then I want to plug in the blank. But now I can substitute back in for u. U is equal to 2x, so this is the same as 1/2 e to the 2x. Now I'm in the x variable. I can use my original limits of integration. I use -1 and 2. So that's going to be 1/2, and now I plug in 2, so that's going to be e to the 2 times 2, and then minus 1/2. Now I plug in the -1, so I get e to the 2 times -1. So that's going to be equal to 1/2 e to the 4th minus 1/2 e to the -2. And that's the exact answer. That's the best you're going to do. This is what you put down on your piece of paper if asked to find the exact answer. If you were actually to evaluate e to the 4 and e to the -2 using your calculator, you get an approximation, and then this will be approximately the same as that. But it's not exactly the same. So this is the right answer. This is not correct.